Thank you. So this is my first Monitorama. I'm really excited. Apologies about my voice, if my voice is a little bit crackly. I run a 4-person startup, and apparently this is just what I sound like all the time now. I'm here to speak about unknown unknowns and how to know them. As I said, my name's Dylan. I run a company called Overmind. Previously, I was a professional services engineer at Puppet for a long time, so I know Portland quite well. But firstly, I want to start with the story of how a printer made me quit my job. So while I was a consultant at Puppet, I was working for a company that will remain nameless. And the gig was going really, really well, but we wanted to get a big win before I left. And at the time, every server had the same root password. This is the sort of arcane knowledge that gets passed down to you on your first day in the operations team, and you're told never to tell anyone because it's never been changed and it's never going to be changed. And so we wanted to deploy SSD, which would mean that users could log in with their actual username and password, and they could have it revoked when they left the company, and all kinds of very nice stuff. And so the plan was to deploy SSD to all of production on a Friday afternoon. Yeah, now, I know this is a bad idea now, and I knew it was a bad idea at the time, but we had done all of the preparation that we reasonably could. We'd followed all the processes, we deployed it in the dev test environment, and we had all of the approvals. Theoretically, we were ready to go. It was the last day of the engagement, so we decided that we're just going to do it. And so we did. And we deployed the change, and we watched the results come in, and they were coming back green, green, green. And so we tried to log in using the old root password, and it still let us in, so we haven't locked anyone out. And then we tried to log in using our new usernames and passwords, and that let us in as well. And at this point, we're kind of done. All we need to do is just sit back and wait for all the rest of the results to come in, and then go to the pub. And we were about T-minus 90 minutes from going to the pub at this point. At T-minus 45 minutes, the phone rang. And somebody said, "Hey, I can't save PDFs anymore. Nobody on the team can save PDFs, and we're at a complete standstill because nobody can save PDFs." And I sort of thought, what? How could we possibly have broken the ability to save PDFs? We were touching the back-end Linux fleet. We didn't touch any Windows, anything, certainly not any laptops. But by the same token, nobody else would have been stupid enough to do a deployment at 4 p.m. on a Friday. So it probably was us. And so I asked a few more questions, and it turns out they're not clicking File, Save as PDF, Save. They're clicking File, Print, and they get a print dialog with a list of printers, which are mostly physical printers in the office, with the exception of one called PDF printer. And we've broken this thing, whatever it is. So now we had to work out what it was. We started with the easiest thing, which was ask around. We asked the team, and they'd been there for a while, and nobody had heard of the thing. Nobody knew what it was. But they had a wiki. And in the wiki, they documented all of the stuff that they were responsible for and all the processes for it and how to upgrade it and stuff like that. And it's not in the wiki. But they have a CMDB, and everything is in the CMDB because it has to be in the CMDB. All of their servers, all of the stuff, and it's not in the CMDB. And so at this point, we're sort of running out of ideas. Thankfully, we know the IP address of this printer. And so we SSH to it, and we get a blinking prompt that says password, and we type in the root password that's been the same for 10 years, and thankfully, it let us in. And so what followed then was a particularly complicated session of infrastructure paleontology, which sort of much like regular paleontology is a hell of a lot more boring and tedious than Indiana Jones makes it look. But eventually, we worked out how the bones of this thing fit together when it was alive. And it turns out that about 10 years ago, somebody bought a physical server and put it in the data center. And its job is to pretend to be a printer And when somebody prints to it, it uses like cups, and it saves that to a PDF and then runs a script, and the script picks up the PDF and moves the file to a mount point. The mount point's on a NAS, and the NAS is on their laptops. And so to the user, it looks like they've saved the PDF to their laptop, but actually it's done this horrible dance all the way around the network and back again. And we've broken this somehow. Turns out we had to then work out how to fix it. Turns out the fix is pretty easy. All we had to do was change a few thousand permissions on the network share, which is easy to do, but not so easy to decide to do. But at this point, everybody had already gone home. We tried quite hard to work out whether anything else depended on the network share being set up with the permissions that it had. And given that we could barely work out that the thing existed in the first place, we really had absolutely no chance of working that out other than just doing it. And so since everybody had gone home, we just did it. And it was fine, amazingly. Everything was fine. It fixed the PDF printing. People could save their PDFs again. Nothing else broke. And so everything was okay, except for the fact that the entire department had gone home early without getting done all of the stuff they needed to get done before the weekend. So not fine. But we did make it to the pub. And at the pub, we were discussing, all right, that wasn't brilliant. How could we have done better there? And I really don't think that we would have thought to test for that beforehand. In fact, if future Dylan had come from the future and said, hey Dylan, you should check to see if there's anything pretending to be a printer and saving things as PDFs and running a script, I would have said, that's so dumb that if I was to check for that, I would have to check for every other possible thing under the sun, and I'd never get any work done. So we wouldn't have checked for it. There was no way to test for it. There was no dev environment for this, amazingly. And so all we could really have hoped to do was pick it up before the users did and fix it before the whole team went home. This is a really good example of an unknown unknown, something that we didn't know that we didn't know. This particular situation is so esoteric that it will hopefully never happen to anybody ever again, but it's in a class of really esoteric problems that are actually very, very common. And so I realized that in general, our industry is not super good at dealing with these sorts of really, really esoteric problems. And I thought that I had a way to fix it. And so I quit my job and I started Overmind and started working on it full time. Before I can talk about any sort of solution, though, I've got to give a bit more background on the problem. Firstly, mental models. A mental model is what allows us to predict what the outputs of a system will be for a given set of inputs. For example, I have a mental model on how driving a car works. I know that if I press the accelerator, it speeds up. If I press the brake, it slows down. Now, I didn't develop that mental model by taking the entire car apart and looking at every single one of the pieces and then predicting how they would interact. I learned that by just driving a car. And the mental models of our applications and systems are often built like this too, from experience in operating them rather than from first principles. And just like no amount of driving a car makes you a mechanic, these mental models that are built from experience don't prepare us properly for when things go wrong. Wood's theorem states that as the complexity of a system increases, the accuracy of any single agent's own mental model of that system decreases rapidly. Woods himself actually conducted a workshop that delved into a number of outages and the role that mental models played. I thoroughly recommend reading the report. It's called the STELLA Report, S-T-E-L-L-A. If you Google that, you'll find it. It's a really interesting read. But what they came across that was common in all outages was, and I'm going to read these because they're important. In all cases, each anomaly arose from unanticipated, unappreciated interactions between system components. There was no root cause. Anomalies arose from multiple latent factors which combined to cause a problem. The vulnerabilities themselves were present for weeks or months before they played a part in the evolution of the anomaly. They were activated by specific events, conditions, or situations, and the activators were minor events, slightly near nominal operating conditions or only slightly off normal situations. And in all of these cases, the outage caused what he called fundamental surprise, which is where the situation refutes your most basic beliefs about how the system works and forces you to rebuild your mental model to take these things into account. These are the unknown unknowns. And I don't think that this is a coincidence. I think that outages will always happen at the edge of your mental model with the things that you don't know that you don't know. Because if you knew about it, you wouldn't have got yourself into that situation in the first place. You would have coded around it, or you've had an alert, or whatever. Even if you only know that you don't know something about a system, that is a known unknown. If I know that I don't know how this new version of Kubernetes will play with my application, I can prepare for that. I can do a deployment in test. I can read the documentation. And I can move it into the known knowns section. But doesn't that sort of mean that it, by definition, can't be solved because these are things that we don't know, and therefore we can't prepare for them because otherwise they'd be known unknowns? And actually, it's a little bit worse than that. As we improve our mental models of our systems, we move more of the simple ways that it can fail into the known knowns section, which leaves only the complex ways. So by improving our understanding of our systems, we're actually making outages more complex. To our credit, we are probably making them less frequent, but they are almost certainly going to be more complex because they're always going to be something you didn't anticipate. And this isn't even the worst part because management have not got wind of it yet. And when they do this. Yeah, so we know that the outages were caused by unknown unknowns, but you've got to think about how that must look to management. We followed all the process and something still went wrong. Therefore, we must need more process. And so that's what you do. You add some process to try and avoid the problem in the future, and that increases the lead time for changes. Compared to high-performing companies, low-performing companies that participate heavily in risk management theater have, on average, a 440 times longer lead time than their high-performing counterparts. That longer lead time leads to a lower deployment frequency. A lower deployment frequency means that every change needs to be 46 times bigger if they're going to keep up with the high-performing companies. Now, spoiler, they don't keep up, but the changes are bigger nonetheless. Larger changes and less practice in doing them means that they're 5 times more likely to fail, and all of the above means that when things do go wrong, they go wrong in a big way and take 96 times longer to recover from. And this is the real demon here. Remember, the thing that started this was a big outage, and we added some more process to avoid it. And of course, the result of this process is another big outage. It's a feedback cycle that feeds back on itself and causes organizations to grind to a halt by adding more and more and more process to try to stop things that may never happen again. You can imagine if I was to go back to this company with the PDF printer and do a production deployment, there's probably a step where before you do a production deployment, you print a test page on all of the printers, and then you do a production deployment, then you print a test page again, and nobody knows why we do that, but it's part of what we do, and obviously it helped once, and it didn't, but anyway. I'm judging by the reaction, but I want to hear. Has anyone worked somewhere that's been affected by this? I see like a wave of hands. Yeah, I thought so. Good. These numbers, by the way, are from the Puppet State of DevOps report in 2017 when it focused specifically on risk management theater. There are more up-to-date State of DevOps reports, but this one specifically focused on it. So that's where those numbers are from if you want to quote them at your boss. All right, so how can we fix it? We've got good tools for using our mental models when problems occur. If we look at observability tools, for example, they let us see the outputs in detail, metrics, traces, logs, and we can apply our mental model and infer what must the internal state of the system be in order for it to have produced those outputs. But they don't really help us to build mental models. In the STELLA report, they found that in all instances, despite the companies having good observability tools and other abstractions, the building mental models work was done exclusively using primal tools, which is the command line. And so what are we doing when we're using the command line? Well, we're not looking at the logs because we already have the logs somewhere. We are looking at the inputs, so the configuration and also the internal state, things like how many replicas are actually running, that sort of thing. There's a potentially dubious but nonetheless sort of right-feeling Gartner statistic that says that 80% of outages are caused by configuration, but also configuration is where all of the how the application's supposed to work information lives. And this is what helps us to rebuild our mental models when our systems are behaving in a way we didn't think was possible. This is stuff like what database server does it point to, what security group is in, what are its rules, who's the last person who changed it, all that sort of thing. If we had tools that monitored our inputs and our internal state, as well as observability tools that monitored our outputs, we'd be able to do things like immediately look at whether a setting has changed or not, find out what's changed and whether or not it might have caused an outage. We could build mental models before making changes that were specific to the things that we were changing, especially if we're changing configuration rather than application code. So at this point, I'm sure some of you are thinking, yeah, but I have good documentation, I have config management. If I want to understand the inputs and the config, can I just read the code? And the answer is kind of. They help to mitigate, but they're not really solutions. Documentation, for example, is basically the best way we have of taking our mental model and putting it somewhere so that somebody else can sort of load it into their brain when they need to. But we know our documentation has problems. I certainly can't stand behind our docs and say all of it is up to date and absolutely correct. But also, as per the Woods theorem, we know that our mental models are going to be incomplete as things get more complex. And so the documentation, because it's just our mental model of the thing, is also going to suffer from that. Config management tends to be more complete because it has to have a lot of information in order to actually go and build the systems. But it still has some limitations. For example, this Terraform code is fairly easy to read, but it doesn't tell us anything about the security group that the EC2 instance is going to have. And changing the security group could absolutely break the application that's running on there. The other thing, which is probably more of a problem, is Terraform code never looks like this. It's never this easy to read. It's every single one of these things will be a variable, which is coming from some other place, and you have to chase all the variables down. And it ends up just being easier to use the command line and go to the source rather than try to be a human Terraform parser. The thing that's common, though, between docs and config management, which is what makes them not a solution, is that they are an abstraction. Abstractions are good for building systems, and we need them. They allow us to compartmentalize our mental models into easier to digest bits so that I can say, hey, Terraform, give me a load balancer, and it gives me a load balancer, and I don't have to worry about how it did that. Documentation follows that pattern as well. It will document the things to pass in to get the load balancer, and it'll document the load balancer you get back, but it often doesn't document exactly how that gets done. And so we need these abstractions in order to build systems, but when we have to fix systems, we know that the problems tend to occur outside of our mental models, so that they're most likely to occur in the gaps where these abstractions meet. As I said, the STELLA report found that even though all of the companies that participated had lots of abstractions that they used to interact with their systems day to day, in every circumstance, they went back to primal tools and raw data when things went wrong. So docs and config management can help to mitigate, but they're not necessarily a solution. So what is? I've been trying to work this out for the past, coming up on 2 years. We can't practice for a specific outage because we know that it's going to surprise us each time, but we can improve our general troubleshooting skills. For example, we can use chaos engineering principles to actually break things and go and fix them, but instead of knowing what the chaos engineering tool is going to do, withhold that from your team so that the team has to do the troubleshooting and work out what's happened as well as the actual fixing in order to get things working again. Doing regular training and drills. When's the last time you practiced finding all the logs and traces for a specific customer or for a specific transaction? I know that I only ever do it when something is actually broken, and I should do it more often because it takes me too long. It should be part of our onboarding. It should be something that we do very regularly. Also, a great deal of our troubleshooting time is spent just trying to find the right information, trying to remember the correct flags for the AWS CLI or the correct query language thing. Interpreting the information is often the easy part. So to fix this, we can make our config a lot easier to discover. For example, Cloud Query is a tool that lets you take all of your cloud configuration and dump it into a SQL database. So we could do that and dump it into Postgres every hour, and suddenly we have a SQL database with all of our AWS stuff in there that we can hit as hard as we want. We don't have to worry about rate limits. We can write our own queries for. We can look at the deltas. That would be fairly useful. If we had kubectl, it could be even simpler. We can just use kubectl to dump the contents of your entire cluster into a Git repo and just git commit that once every hour. It sounds kind of dumb because these are really very, very simple things to do, but it can seriously help. For example, do you know how to get the list of all the places a security group is used in AWS? You basically don't. There are entire blog posts dedicated to how to do it. It involves hitting every single AWS API with a certain set of queries to work out whether that security group is used, and it's horrible. But if you had dumped all of your AWS to a big folder of text files, you could use grep and it would take a couple of 100 milliseconds and you'd know exactly where it was. So even though it seems a bit dumb and there's probably some security considerations and stuff that you'd have to deal with, in a pinch, when things are down, it's a hell of a lot quicker to search through simple stuff like this and then maybe go and cross-reference to actually AWS than it is to remember all of the these complex tools under pressure. Once you've made your config discoverable, though, the harder part is helping people to understand the relationships. Just because you can grep for the security group in a bunch of places doesn't mean you understand how they actually interact. The way that I'm solving this, and I think that we can solve this, is similar to the way a web crawler works. So if we look at the details of something, in this case it's a HTTP endpoint, there's a bunch of breadcrumbs that we can sort of follow to find out more. This endpoint has got a certificate, which we could parse and get details from. It's got a DNS record that we could query and get the results of. And if we did that, and then did it again and did it again, we could go from the HTTP endpoint to the DNS, to the IP, to the load balancer, to the actual infrastructure that runs the application. And eventually we'd have a big directed graph that looks like this, which we could use to do a bunch of interesting things. And they wouldn't require the user to understand the system. This is really important. We know that when things go wrong, they are going to refute our mental models. So our systems have to assume that the user doesn't know what they're looking at, because when it's broken, you won't know, because it will be behaving in a way you thought was impossible. So what we can do with this sort of information, because we haven't required the user to give us anything to get it, we could take, say, a plan change from Terraform plan and then look at, if Terraform touches this thing here, what is the blast radius going to be? What potentially could be impacted? Given that, we could take snapshots of it and look at the changes before and after to make sure that if I've made a change, it has not only affected the things I thought it was going to affect, but also a bunch of, maybe, the load balancer has gone unhealthy, or the 95th percentile has changed massively for this particular thing that we're monitoring. we can find the downstream impacts very easily. We could also cross-reference this sort of infrastructure config data with a database of applications and work out what applications might be affected if these things are affected. If we do this for each change, not only do we get more confidence that our changes aren't going to break things, but we can create sort of a focused database with the details of everything that's changed and answer questions like, who was the last person to touch something that could potentially have affected this application, what was changed, etc. This is what I've been working on for the past 2 years. So we are working on this now. We're looking for feedback. I can't think of a better room of people to ask for feedback, so I'm doing that now. If this is something that sounds interesting to you, come and speak to me. I'd love to show you what we're working on and get a little bit of feedback on it and give you access. Hopefully people will be getting access in the next week if I get some pull requests closed. So if you're interested, I'd love to hear from you. So what did we learn? We learned that outages are always going to happen outside of our mental models. They're always going to be caused by the thing that we didn't know, because if we knew it, we wouldn't have got into that situation in the first place. Therefore, tools that require mental models in order to use them aren't going to help because we know our mental model is going to be wrong. The situation will have forced us to question our most basic assumptions. Therefore, we need to be making our systems more discoverable on the fly. When things are broken, we need to be able to discover the config and the changes and the dependencies as quickly as we can. So I want you to think about this next time you have a problem. How long did it take you to find the right data? Is there a way I could have made my configuration more discoverable? I implore you all to read the STELLA report. It's really, really good. STELLA. It's on GitHub. You'll find it if you search for that. And come and chat to me if you have any cool ways that you're doing this today. I'd love to hear about it. Thank you.